just make sure that you will complete your presentation within 10 minutes. Okay. So there is no need to read up all the things. Just try to explain whatever you have learned from the chapter number 2. Okay. So every student will have 10 minutes time. Yes, sir. Please start.
Okay, ma'am, just to wait. Hello, ma'am.
Yes, sir.
Ma'am, please ask to some other student. When I just connect my network, then I'll just inform you, ma'am.
Okay. So Meghavat.
Ma'am, today this is my first class, ma'am.
Okay. Next, Parul.
Yes, ma'am.
Yeah. Please give the presentation.
Ma'am, I have not made a presentation. I was not present in the previous class, so I was not aware about this.
Then you must be aware about the chapter number 1 presentation. Isn't it?
Okay.
So have you prepared the chapter number 1?
Yes, ma'am, but not completely, ma'am. That day only I made the chapter 1 presentation. Okay, ma'am, I will share.
Go ahead with chapter 1.
Okay. Ma'am, it will take a few minutes, ma'am.
Okay. I will come back to you later. Praveen?
Yes, ma'am.
Start करिए. Praveen?
Yes, ma'am. It is using, ma'am.
Yes, Praveen, it is visible.
Ma'am, remote sensing platform and sensor. Remote sensing platform and sensor for studying, ma'am. It is a component of the remote sensing, or remote sensing is platform. Platform basically 3 type: ground-based platform, airborne platform, spaceborne platform. First, ground-based platform, ma'am, it is used to record detailed information about the surface very closely. Example: ground vehicle, tower, air balloon, kite. Second, ma'am, airborne platform. Airborne platform used to collect a very detailed image and facility to collect of data over any position of Earth surface and any time, but is very expensive platform. Example में होता है इसका aeroplane, high altitude aircraft and helicopters. मैम इसको हम मेजर करते हैं अर्थ ग्राउंड से 50 किलोमीटर. थर्ड मैम होता है हमारा स्पेस वन प्लेटफॉर्म. स्पेस वन प्लेटफॉर्म होता है मैम इट कैमरा सैटेलाइट इनिशियली टू लो अर्थ ऑर्बिट सैटेलाइट फॉर द मिलिट्री पर्पस हैव टू आल्सो हैव बीन यूज्ड टू सिविलियन रिमोट सेंसिंग फ्रॉम द स्पेस. इसके एग्जांपल्स होते हैं मैम इसमें मैम रॉकेट सेटल हम करते हैं विद इन 250 टू 300 किलोमीटर अबव द अर्थ सरफेस. एंड सेकंड स्पेस स्टेशन जो मैम इसको हम सेटल करते हैं मतलब ग्राउंड स्पेस मतलब ग्राउंड सरफेस से 300 टू 400 किलोमीटर. एंड लो लेवल सैटेलाइट या पोलर सैटेलाइट जो हम इसको मैम जो सेटल करते हैं वो अर्थ सरफेस से 700 टू 1500 किलोमीटर. एंड फोर्थ मैम हाई लेवल सैटेलाइट या हम जियो स्टेशनरी सैटेलाइट इसको हम मैम अर्थ सरफेस से का नाम 36,000 kilometer above the Earth's surface. Basically, ma'am, satellite are ma'am satellite object which revolve around another object. In this case of the Earth, in the another object. Basically, ma'am, sensors. Sensor is basically 2 types: active and passive sensor. Passive sensor it detect natural energy that emit or reflected by the object and sensor being the observed. Reflect sunlight is the most common surface or radiate measured by the passive sensor. Active sensor होता है मैम. Active sensor, it is the transmit their own signal and this measures the energy that the reflect and transmit black or scatter black from the target. Example इसमें मैम होता है radar and sonar. उसके बाद मैम characteristic of image remote sensing instrument. This can मैम इसमें होता है this characteristic of image remote sensing instrument operating the visual and the infrared spectrum region can be submerged in terms of the spectral and radiometric resolution. मैम इसमें basically 3 type of resolution. Resolution मैम होता है it is the ability of sensor or differentiate between spatial distance, spectral length, and emissivity and time. Basically 4 type of resolution: spatial resolution, spectral resolution, radiometric resolution, and temporal resolution. Spatial resolution, it is the measure of the smallest angular or linear. Hello, ma'am.
Yes, Praveen.
Spatial resolution, it is the measure of the smallest angular and linear spectral between two objects and can be resolved by sensor. मैम इसमें एग्जांपल होता है enhanced thematic map, least third, least fourth. उसके बाद मैम होता है spectral resolution, the number of dimension of the specific.
किस चीज का दे रहे हो? लिस्ट का enhanced thematic mapper, ये किसका एग्जांपल यहाँ किस चीज का दे रहे हैं?
मैम इट मतलब स्पेशियल रेजोल्यूशन जो हम मेजर करते हैं इस मतलब इस लीनियर मेजरमेंट यूनिट होती हैं मैम.
तो उसमें ये वाला
एग्जांपल हम
नहीं समझ में आया आपका. ETM और लिस्ट, ये एग्जांपल क्या दे रहे हैं यहाँ पे?
मैम इट्स का नाम जो हम कोई मतलब पिक्चर्स लेते हैं तो मतलब मैम इसका जो लिस्ट थर्ड होता है मतलब 23.5 मीटर का मतलब इसका रेजोल्यूशन होता है.
इसके बीच में आप लिस्ट नहीं बोलोगे, इसका एग्जांपल बोलोगे कि फॉर एग्जांपल द स्पेशल रेजोल्यूशन ऑफ लिस्ट इज 23.5. ठीक है, द स्पेशल रेजोल्यूशन ऑफ ETM प्लस इज 30 मीटर, ऐसे बोलोगे. ठीक,
ओके मैम,
चलिए कंटिन्यू करिए.
Next, ma'am, spectral resolution. The number of dimension and specific wavelength interval in the electromagnetic spectrum to which the remote sensing instrument in the sensitive, or the bandwidth and number of band used for the collective this data. Third, ma'am, radiometric resolution. The sensitive of remote sensing detector to make difference in the signal strength of the record to radiant flux reflected to or emitted from the trains. Fourth, ma'am, temporal resolution. It refers to how often to record the imagery of the particular area. For example, ma'am, IRF P6 has a temporal resolution of 24 days. Next, ma'am, optical near infrared and thermal. For example, ma'am, another kind of advantage very high resolution radiometric and NPOSS. The advanced very high resolution which are carried by American ANOS series of the satellite, which is the instead to the meteorologically observation system. The image acquired by the AVR has to, however, in the widely used in the land cover monitoring of the global and the continuous scales. Next, MODIS. MODIS is the wide field to view the instrument that the carried by both of US Terra and the acquired satellite. As noted earlier, the Terra satellite are the equatorial crossing time of hello ma'am.
Yes, Praveen.
Okay.
क्या हो गया?
Next, ma'am, ocean observing instrument. It is the number of detector ocean object the satellite has been placed on the orbit in the part of 25 year. Measured from the instrument carried by this satellite have been used to the study of marine food chain and the Role of the ocean in the biochemical cycle, such as the carbon cycle. Next, ma'am, Landsat instrument. First, ma'am, is basically four type of Landsat instrument. First, Landsat multi-spectrum scanner. Second, thematic map. Third, enhanced thematic map. Fourth, ma'am, Landsat data content mission.
प्रवीण
First,
प्रवीण इसके
ma'am.
नाम जरा ध्यान से पढ़िए। पहली बात तो लैंडसैट है, ठीक है, लैंडसाइट नहीं है, लैंडसैट है। दूसरा चीज
Okay,
थीमेटिक मैप
Landsat.
नहीं है, थीमेटिक मैपर है। ETM इनहांस थीमेटिक मैपर है। तो नाम ध्यान से पढ़िए। ये अलग अलग सेंसर्स हैं जो लैंडसैट सैटेलाइट में यूज हुए हैं ओवर द टाइम। कंटिन्यू करिए।
Okay, ma'am. First, ma'am, Landsat multi-spectrum scanner. Landsat 1, original called the Earth Resource Technology Satellite on ERTS-1, was the first civilian land observation satellite. It was launched into a 919 kilometer sun synchronous orbit on 23rd July 1972 by NASA and operated successfully until January 978. A second similar satellite
900 है कि
Landsat,
1900 है प्रवीण?
ma'am, 1978. A
तो
second
इसको एक
similar.
मिनट में वाइंड अप करिए। 10 मिनट्स हो रहा है आपका, लास्ट मिनट है, वाइंड अप करिए इस प्रेजेंटेशन
Okay, ma'am. मैम उसके बाद स्पॉट सेंसर हम यूज लिए हैं। स्पॉट सेंसर मैंने मतलब स्पॉट HBR लिया, उसके बाद रजिस्ट्रेशन लिए हैं, उसके बाद उसके एडवांटेज वगैरह मैम। उसके बाद ब्रीफ मतलब हिस्ट्री ऑफ रेडार, उसके कुछ फी पॉइंट लिए हैं जिसमें यूरोपियन स्पेस एजेंसी, उसके बाद सिस्टमेटिक अप्रोच, उसके बाद रेडार साइट है, टेरा ESR-X है एंड अलोफ।
ओके, थैंक यू प्रवीण। नेक्स्ट रुचि।
थैंक यू मैम।
यस रुचि।
Yes, ma'am.
हाँ,
Yes, ma'am.
यस रुचि, स्टार्ट द प्रेजेंटेशन।
Okay. Ma'am, is it visible?
Yes, it is visible.
Good morning, ma'am. This chapter is remote sensing platforms, and this chapter includes introduction, characteristics of imaging, remote sensing instrument.
Your presentation in the slideshow mode.
Okay, ma'am. मैम सॉरी आई कांट, मुझे मैम पता नहीं इसके बारे में मैम। स्लाइड्स
F5 प्रेस कर दीजिए। F5 की।
सॉरी मैम,
स्लाइड ये फ्रॉम द बिगनिंग आ रहा है ना?
यस मैम।
उस पर प्रेस कर दीजिए। लेफ्ट में सबसे पहला बटन देखो। लेफ्ट हैंड साइड जाइए। कंटिन्यू।
This chapter includes introduction, characteristics of imaging, remote sensing instrument, optical, near-infrared and thermal imaging sensor, microwave imaging sensor. Introduction. This chapter contains a description of nature and characteristics of digital images of produced by aircraft and satellite-borne sensor operating in the visible, infrared and microwave region of the electromagnetic spectrum. A new and interesting means of collecting remote sense data is by mounting instrument on unmanned aerial vehicle, which can remain airborne for long periods and provide a stable platform. The general characteristics of imaging remote sensing instrument operating in the optical wavelength, namely their spatial, spectral, temporal, and radiometric resolution. Characteristics of imaging remote sensing instrument. First is spatial resolution. The most commonly used measure based on geometric properties of the imaging system is its instantaneous field of view. The IFO is the IF defined as the area on the ground that is that in theory is viewed by the instrument from the given altitude at any given instant in time. The IFOV becomes smaller at lower altitudes and increase as the altitude increases. So, although the spatial resolution of the Landsat 1 to Landsat 3 multispectral scanner. Second is spectral resolution. Spectral describe the ability of a sensor to define fine wavelength intervals. The term spectral resolution refers to the width of spectral bands measured in micrometer or nanometer. Third is radiometric resolution. Radiometric resolution or radiometric sensitivity refers to the number of digital quantization levels used to express the data collected by the sensor. The greater number of quantization levels details in the information collected by the sensor. Optical, near and infrared and thermal imaging sensor. The aim of this section is to provide brief details of a number of sensor systems operating in the visible and infrared region of the electromagnetic spectrum. First is a long track scanning radiometer. The primary purpose of this instrument is to make accurate measurements of global sea surface temperature of climate research purpose. ASTR ATSR is a interesting. It provides two views of target from different angles. Advanced very high resolution radiometer AVHRR and NOPESS VIRRS. The imaginary required by AVHRR has, however, have been widely used in land cover monitoring at global and continental scales. The swath width of the AVHRR is of the order of 300 km. The TIROS program
AVHRR is the multispectral or
is by National Polar Orbiting. Sorry, ma'am. Yes, ma'am.
The AVHRR that you are mentioning over here, it is the example of multispectral sensor or a hyperspectral sensor?
Ma'am, this is high resolution radiometer, ma'am.
I'm repeating the question whether it is a multispectral or a hyperspectral.
Ma'am, voice नहीं आई ma'am.
Please continue.
Ma'am, please repeat again.
I am asking whether the AVHRR is the hyperspectral or a multispectral sensor.
Ma'am, multispectral sensor.
Okay, please continue.
The TIROS program is to be replaced by the National Polar Orbiting Operational Environmental Satellite System. The imaging capabilities are provided by the Visible Infrared Imager Radiometer suite which has 9 VNIR channels, 8 mid-infrared bands, and 4 TIR bands. The VIIR replace the AV, HRR, and moderate resolution imaging spectrometer, which is called Moody's instrument. Now talking about Moody's, the moderate resolution imaging spectrometer is a spectroradiometer is a key instrument on board the Earth observer platforms designed to monitor the Earth's atmosphere, ocean, and land surface with a set of visible in NIR, MIR, and thermal channels. The TERA has an equatorial crossing of 10. Equatorial crossing time is 13.30. Now the topic is ocean observing instrument. The study to study the marine flood chain and role of ocean. 1 second. To study the marine flood chain and role of ocean in biogeochemical cycles such as carbon cycle.
Yes, Ruchi, quickly continue. Quickly complete your
Yes, ma'am.
presentation.
Observing instrument are given below. The coastal zone color scanner experiment, sea viewing wide field of view sensor, ocean sat 2, Moody's ocean color and temperature sensor. IRS ISS, the first Indian remote sensing satellite called Bhaskara, first was launched in 1979. Later developments led IRS program IRIS first A and IRS first B, the acronym of linear imaging self-scanning sensor. LISS first was the multispectral instrument with a 76-meter resolution in 4 wavelengths. LISS2 used the same 4 wave bands in VNIR but collected data at a spatial resolution of 36 meter. The IRS first C carried an improved LISS numbered plus a 5-meter resolution panchromatic sensor. LISS3 includes a mid infrared band in place of blue-green band. Landsat instrument first is Landsat multispectral scanner. Second is Landsat thematic mapper. Third is enhanced thematic mapper plus.
Ruchi,
Yes, ma'am.
what is the spatial resolution of ETM plus?
I don't know, ma'am.
Ruchi, it is appearing that you have just placed the content in your slide. You haven't read, go through the chapter number 2. Is it? आपने बस उसको प्रेजेंटेशन बनाने के लिए कंटेंट वहां से कॉपी पेस्ट कर दिया स्लाइड पर और काम खत्म किया, उसको ध्यान से पढ़ा नहीं, इवन अपनी स्लाइड्स को भी नहीं पढ़ा. सामने सामने लिखा है 15 मीटर रेजोल्यूशन इन पैनक्रोमैटिक, 60 मीटर इन TIR, सामने लिखा है कि नहीं? और फिर आप बोल रहे हो कि मुझे नहीं पता. बाकी लैंडसेट का तो 30 मीटर होता ही है बाकी बैंड्स के लिए. तो जब प्रेजेंटेशन बनाए, प्रेजेंटेशन आपने बनाया ये अच्छी चीज, लेकिन प्रेजेंटेशन बनाते टाइम उसका पर्पस ये नहीं है कि आप स्टूडेंट्स यहाँ आकर के 10 मिनट तक बोलते रहें. उस पूरे प्रेजेंटेशन को बनवाने का पर्पस ये है कि आप लोग उस चीज को सीखें, है ना, कि आपने कुछ लर्न किया. और ये इवन SIP पे उसको रेफर किया जाए तो आपको ये हेल्पफुल हो, इसलिए ये पूरा का पूरा कराने का पर्पस है. किया वो प्रेजेंटेशन दे दिया, लेकिन अभी जो टाइम है उसमें चैप्टर फर्स्ट एंड सेकंड लिलिसन केपर का एक बार अपने लिए रिमोट सेंसिंग को एक तरीके से वापस के लिए रिवाइज करने के लिए उस बुक को पढ़ेंगे। आप जो भी नोट्स पहले पढ़ा करती थी अपने प्रिंसिपल्स ऑफ रिमोट सेंसिंग सब्जेक्ट में, उसको एक बार देखिए। ठीक है, चलिए, थैंक यू रुचि। नेक्स्ट शिवम।
मैम मेरा लैपटॉप एग्जाम में क्या हुआ मैम?
क्या प्रॉब्लम है शिवम?
मैम जो मेरा लैपटॉप है मैम वो सिस्टर के मतलब सिस्टर एग्जाम दे रही है मैम उस पे। मैम अभी तो लैपटॉप यूज नहीं कर सकता।
तो पढ़ा होगा ना, चैप्टर 2 रीड किया है कि नहीं किया है?
नो मैम।
इसका क्या सोल्यूशन लिया जाए शिवम, बताइए। लैपटॉप का प्रॉब्लम कोई वो नहीं है, वो एक सबके साथ होता है। किसी दिन किसी का कुछ प्रॉब्लम है, नहीं चल रहा है, या घर में किसी और को रिक्वायरमेंट है, उसके पास गया हुआ है लैपटॉप, इट्स ओके। बट एटलीस्ट अटेम्प्ट तो करो बिना लैपटॉप के भी। जैसे हम लोग पढ़ाते हैं, अगर अगर स्लाइड्स नहीं भी चल रही है तो भी पढ़ाएंगे ना। तो उसी तरीके से चैप्टर 2 अगर आपने रीड किया है, पढ़ा है, तो लैपटॉप नहीं भी है तो भी आप उसको प्रेजेंट कर सकते हो कि जो आपने कंटेंट उसको पढ़ा है। ओनली सजेशन इज कि आपका ये पर्पस रिमोट सेंसिंग का रिवीजन के लिए है, तो अगर ऐसे नहीं पढ़ रहे हो तो अपना जो भी आपने पहले रिमोट सेंसिंग का पढ़ा उसको एक बार देख लीजिएगा। चलिए नेक्स्ट सुमित।
Yes, ma'am. Very good morning to everyone. Today I'm going to present my presentation on the second chapter, that is remote sensing platforms and sensors. Ma'am, is it visible?
Yes, it is visible.
This chapter discusses with a description of the nature and characteristics of digital images of Earth's surface produced by the aircraft and satellite-borne sensors, and it also discusses the different type of resolutions of specific sensors and operating in each of these spectral regions and examples of typical applications. And it deals with the instrument used for remote sensing in the optical, near infrared, and thermal infrared and microwave wavebands. The major properties of remote sensing, in that we include the 4 types of resolutions, that is spatial resolution, spectral resolution, and temporal and radiometric resolution. By spectral resolution, we mean that the number and size of bands in the electromagnetic spectrum that a remote sensing platform can capture. And by spatial resolution, we mean the smallest angular separation between two objects. Suppose there is an object which is of distance xy, that and the angular distance, that is solid angular distance between that will be called as the spatial resolution. Temporal resolution, by temporal resolution we refer to the frequency at which imagery is recorded for a particular area. That means it is related with the time between two successive imagery. Fourth is radiometric resolution. Radiometric resolution is basically the sensitivity of remote sensing platform to detect slight differences in energy. Suppose there are two objects adjacent to each other, and the ability of the sensors to distinguish between both of these two objects without averaging their energies. That is called the radiometric resolution. Next one is characteristics of the imaging remote sensing instruments. Here, that the previous was the major characteristic of imaging of remote sensing instruments, and here are some other, that is the manner and of operation of the scanning device that collects the image and geometrical properties of the image produced by the system. Here we basically understand why we need the different type of resolutions. Suppose there is dynamic system like weather forecasting and atmosphere, and oceans, then at that moment a high temporal resolution is required. Suppose one's aim was to compare the spectrum of given pixel, the number of bands is also important in that case. That is the spectral resolution. Next one is the radiometric resolution of a sensor determines the level of details, that is distinguishing feature between two objects. That it allows for the monitoring of extremes like snow and cloud tops at one end of the range to deep clear water and other. Therefore, from this discussion, it follows that the different resolution of an Earth observing system should be selected with the aim of the investigation in mind. It means that what we are going to investigate, what we are going to take image, on that basis, all the different resolution will be depending. First is spatial resolution. Scientist Townsend uses 4 criteria to define spatial resolutions. These criteria are first one is geometrical properties of imaging system. Second is ability to distinguish between targets, that is supposed to 2 targets between them. And the third one is ability to measure the periodicity of repetitive target, that is time period between the 2 targets. The ability to measure the spectral properties of small targets. On the basis of this, we will discuss that based on the geometric properties, we use a measure like IFOV, that is instantaneous field of view. Instantaneous field of view is basically a kind of solid angle between 2 distances. It is defined as the area on the ground that is viewed by the instrument from a given altitude at any given instant in time. Next, on the basis of that second criteria, that is ability of the device to distinguish between specific targets, there are 2 measures again. First one is the fact method. The first method uses the fact that point spread function of a point source is a bright central disk with the bright and dark rings around it. It basically means that we are having concentric type of circles in which bright and dark rings will be present. That Rayleigh used that. The Rayleigh criterion assumes 2 equally bright point sources and specifies that 2 sources will be distinguishable. That is, it means that if we are using a concentric type of circles in which we are using first is a bright circle, then next one is dark circle, and then it will be distinguishable on the image if the bright central disk of the one falls on the first dark ring of the point spread function of the other. This minimum separation between the point source to achieve this degree of separation on the image is a measure of spatial resolving power of imaging system. The second method assumes that the targets are not points. It means that it is not a point spread function. It is kind of linear parallel objects with known separation that is related to their spatial frequency. And the spatial frequency of the objects such that they are just distinguishable is a measure of spatial resolving power. Then comes spectral resolution. Before starting, we need to understand one term, that is panchromatic image. Actually, panchromatic image is a single band image that measures upwelling radiance in the visible waveband. The term spectral resolution refers to the width of these spectral bands measured in micrometer or nanometer. The position in the spectrum, width and number of spectral bands determines the degree to which individual targets, that is vegetable species, crop or rock types, can be discriminated on the multispectral image. The use of multispectral imagery can lead to a higher degree of discriminating power than any single band taken on its own. The width and position of the spectral bands are determined by the spectral reflectance curve of target, which we have already read in Principle of Remote Sensing, that the reflectance curve along with the transmission to provide for the more reliable identification of particular targets on a remotely sensed image. The spectral resolution of a sensor must match up as closely as possible this spectral reflectance curve of the intended target. Now, there is you can say that a trade between a resolution of different resolution and other factors. So there is a price to pay for high resolution. So actually there is a ratio between signal and noise which is being traded for high resolution. So all signals contain some noise or random error that is caused by electronic noise from the sensor and from effects introduced during transmission and recording time. Therefore, this SNR, signal to noise ratio, is the measure of purity of signal. So increasing increasing the spectral resolution reduces this signal to noise ratio, because when we increase the spectral resolution, we are basically narrowing the band. So if we are going to narrowing the band, means we are going to decrease the signal. Then if we are going to decrease the signal, then signal to noise ratio will be ultimately decreased. And that is being discussed here, that increasing the spectral resolution reduces the SNR of sensor output, because the magnitude of radiance in narrower spectral band is less than that of wider bands, while the inherent noise level remains constant. The time available to measure the energy emanating from each point along the scan line, termed as a dwell time or integration time, is greater for push broom scanner. Actually, this point is the solution for above. The time available to measure the energy emanating from each point along the scan line is greater for push broom scanner, because the individual detectors sees more photons coming from a given point than the detector is in an electromechanical scanner or whisk broom scanner, which looks at the points only for a short time. Hence, narrower bandwidth and larger number of quantization level are theoretically possible without decreasing the SNR to unacceptable levels. Now, radiometric resolution. Radiometric resolution or radiometric sensitivity refers to the number of digital quantization level. By actually quantization, we mean that we are breaking the continuous range of into a discrete number of levels, like we are breaking the things into a number. Here it is written that number of digital quantization level used to express the data by the sensor. In general, the greater the number of quantization level, the greater the detail in information collected by the sensor. Two scientists, Forty and Barrett, note that estimates of relationship between the leaf properties and reflection remote sensing platform and sensors 39 and transmittance properties are quite sensitive to the radiometric resolution of the instrument used. Bernstein used a measure known as entropy to compare the amount of information in terms of bits per pixel for 8-bit and 6-bit data for two images. This entropy measures, it is represented by H, which is equals to minus summation from I is equals to 0 to K, Pi log base to Pi, where K is the number of gray levels, for example 64 or 256, and Pi is the probability of level I, which can be calculated from Pi, which is equals to Fi upon Nm. In this formula, Fi is the frequency of occurrence of each gray level from 0 to K minus 1, and Nm is the number of pixels in the image. That's all, ma'am. Thank you, ma'am.
Okay. Next, Sunil.
Yes, ma'am.
Ma'am,
Yes, Sunil.
ma'am,
Please wait, ma'am.
ma'am भगत
सुनील आपका समझ नहीं आ रहा, क्या बोल रहे हैं, रिपीट करिए.
मैम भगत बोल रहा है, कुछ बोलना चाह रहा है.
मैम भगत बोल रहा हूँ.
हाँ, बताइए भगत.
Ma'am, I was not aware of the chapter 2 presentation, so I didn't make the PPT.
भगत मुझे नहीं समझ आ रहा, रिपीट करिए.
Ma'am, I was not aware of the presenting the chapter 2 presentation, so I didn't make the PPT.
Okay. Yes, Sunil, continue.
Yes, ma'am. Today topic is the remote sensing platform and sensor. Remote sensing platform is the structure or vehicle on which remote sensing instrument center are mounted on suitable stable platform. These platforms can be ground-based, airborne, or space. ground base. Characteristic of imaging remote sensing instrument. First is the spatial resolution. Spatial resolution means a measurement of the smallest object that can be resolved by the sensor. In the spatial resolution, the term used is IFOV, instantaneous field of view. IFOV is defined as the area of the ground that is viewed by the instrument from a given altitude at any given instant in time. IFOV can measure two ways, angle and equivalent distance. IFOV becomes smaller at lower altitude and increase at the increased altitude. Second is the spectral resolution. Spectral resolution describes the ability of sensor to define the fine wavelength intervals. Microwave SAR image collected by the instrument on board satellites are generally recorded in a single wavelength as the panchromatic image collected by the sensor. In signal to noise ratio, SNR is the measure of the purity of a signal. Increase the spatial resolution, reduce the SNR of the center output, become the magnitude of the radiance in narrower spatial bands is lesser than that of wider band, while the inherent noise level remains constant. Third is the radiometric resolution. Radiometric resolution refers the number of digital quantization level used to express the data collection by the sensor. The greater the number of quantization level, the greater detail in the information collected by the sensor. Next topic is the optical near-infrared and thermal imaging sensor. It is the provide a brief detail of number of sensor system operating in the visual and infrared region of the electromagnetic spectrum. First is the long track scanning radiometer. ASTR. ASTR is a single band grayscale image that has been produced by a technique called pseudo color. The image covers the 11 micrometer region in the TIR. Cold area are shown in blue and purple, while warmer area are shown the yellow and red. It has three TIR channel centered at 3.7 micrometer, 10.8 micrometer, and 12 micrometer, plus a NIR channel centered at 1.6 micrometer. The primary purpose of ATSR is the make accurate measurement of global sea surface temperature for climate research purpose. Second is the advanced very high resolution radiometer. It is carried by the American NOAA series of satellites. Was intended to be a meteorological observance system. The image acquired by ABHRR has been widely used to land cover monitoring at global and continental scales. The TIR channel are used to see surface temperature determination and cloud mapping, whereas the BNIR channel are used to monitoring land surface process such as snow and ice melt. MODIS. MODIS is the wide field of view instrument that is carried by both the US Terra and Aqua satellites, so that two MODIS instruments can be used in the collecting information relating the diurnal variations in the availing radiant that is related to the characteristic and condition of land surface, ocean and atmospheric variables. It is the conventional radiometer used the scanning mirror and measured in 36 spectrum band 1 to 19 are collected during the daytime segment of the orbit, and band 20 to 36 are collected during the nighttime segment. Ocean observing, yes ma'am.
The slides are not changing. You are still at the slide number 1. Please unshare your slides and share it again. Unshare the screen and share it again.
Can you visual, ma'am?
Slide number 1 is visible. Yes, now it's changing.
Yes, ma'am. IRS LISS, the first Indian remote sensing satellite called Bhaskara, was launched in 1979. LISS is the linear imaging self-scanning sensor. LISS-1 was the multispectral instrument with a 76-meter resolution in 4 wavelength. LIS-2 used the 4 wavelength and resolution of 36 meter. Third is LISS-3 includes the mid-infrared band in place of the blue-green band. The spatial resolution is 36 to 25. LISS-4 spatial resolution is 5.1 meter. Landsat instrument.
सुनील,
Landsat, yes, ma'am.
लैंडसेट का लेटेस्ट कौन सा सेंसर है जो हम लोग यूज करते हैं? किस डेटा को लेटेस्ट, कौन सा लेटेस्ट डेटा है जिसे यूज किया जाता है?
Ma'am, Landsat data community mission.
क्वेश्चन सुना?
ATM++.
क्या बता रहे हैं? कौन सा सबसे लेटेस्ट सेंसर है जिसके डेटा को यूज किया जाता है लैंडसेट के?
Sorry, ma'am.
लैंडसेट एमएसएस का रेजोल्यूशन कितना था?
Landsat misses का मैम 30 मीटर.
एमएसएस का 30 मीटर है।
Yes, ma'am. Landsat का मैम 30.
आप लोग पता नहीं कौन सी बुक से पढ़ करके आ रहे हैं। चलिए आगे चलिए, उसको वाइंड अप करिए 1 मिनट में।
Ma'am, second is Landsat thematic map and third is enhanced thematic map plus and fourth is Landsat data continuity mission and the sport sensors. First is the sport is HRB and second is sport follow on program. Advanced spaceborne thermal emission and reflection radiometer. ASTER is the moderate resolution multi-spectrum sensor. Accurate data in the 3 spatial regions using the separate radiometer. Each region for the VNIR sensor spatial resolution is 15 meter. The USB IR band have been specified in 30 meters and well TR image have been 90 meters. And the second is high resolution commercial and small satellite system. And next topic is the microwave imaging sensor. The European Space Agency's synthetic aperture space-bound radars, RadarSat, Terra, SAREX, and Cosmo, SkyMed, and the ALOS Pulsar.
Okay, Sunil. Thank you. Next, Yashovardhan.
Yes, ma'am.
Please start the presentation.
Good morning, everyone. Today I am here to give a presentation on the topic remote sensing platforms and sensors. First is platforms and sensor. There are various remote sensing platforms and sensor. First, by remote sensing platform, we mean that the vehicle that carries remote sensing device. It can be ground-based, airborne or airplane-based, space-borne or satellite-based. Sensor is the device which records wavelengths of energy. Examples are camera and scanner. Early platforms and sensor. Remote sensing has a long history, but its main use started in the World War II when countries used pigeons to spy their counterparts to get vital information. Balloons and pigeons were used for remote sensing in the 18th and 19th centuries, but in modern terms, aircraft mountain systems were developed during the early part of the 20th century, initially for military purposes. Now we will discuss about sensor platform. In order for a sensor to collect and record the energy reflected or emitted from a target or surface, it must reside on a stable platform removed from the target or surface being observed. Platforms of remote sensor may be situated on the ground, on an aircraft or balloon, or some other platform within the Earth's atmosphere, or on a spacecraft or satellite outside of the Earth's atmosphere. Ground-based sensors are often used to record detailed information about the surface, which is compared with the information collected from aircraft or satellite sensors. Aerial platforms are primarily stable wing aircraft, although helicopters are occasionally used. Aircraft are often used to collect very detailed images and facilitate the collection of data over virtually any portion of the Earth's surface at any time. In space, remote sensing is sometimes conducted from the space shuttle or more commonly from satellites. Satellites are objects which revolve around another object, in this case, the Earth. For example, the Moon is a natural satellite, whereas man-made satellites include those platforms launched for remote sensing, communication, and telemetry, location and navigation purposes. Because of their orbits, satellites permit repetitive coverage of the Earth's surface on a continuing basis. Cost is often a significant factor in choosing among the various platform options. Now we will discuss about remote sensing satellite and its orbits. When a satellite is launched into the space, it moves in a well-defined path around the Earth, which is called the orbit of the satellite. Gravitational pull of the Earth and the velocity of the satellite are the two basic factors that keep the satellites in any particular orbit. Spatial and temporal coverage of the satellite depends on the orbit. There are three basic types of orbits in use. Geosynchronous orbits, polar and near polar orbits, sun-synchronous orbits. Now we will discuss the characteristics of imaging remote sensing instruments. Remote sensing images are characterized by their spectral resolution, spatial resolution, radiometric resolution, and temporal resolution. First is spatial resolution. Sensors on board platforms far away from their targets typically view a large area, but cannot provide great detail. The details discernible in an image is dependent on the spatial resolution of the sensor and refers to the size of the smallest possible feature that can be detected. The spatial resolution of passive sensor depends primarily on their instantaneous field of view. The IFOV is the angular cone of visibility of the sensor, which is shown by A in the image, and determines the area on the Earth's surface, which is seen from a given altitude at one particular moment in time, which is shown by B in the figure. The size of the area viewed is determined by multiplying the IFOV by the distance from the ground to the sensor, which is shown by the C in the image. This area on the ground is called the resolution cell and determines a sensor's maximum spatial resolution. Most remote sensing images are composed of a matrix of picture elements or pixels, which are the smallest units of an image. Image pixels are normally square and represent a certain area on an image. It is important to distinguish between pixel size and spatial resolution. They are not interchangeable. If a sensor has a spatial resolution of 20 meters and an image that sensor is displayed at a full resolution, each pixel represents an area of 20 meter cross 20 meter on the ground. In the case of the pixel size and resolution are the same. However, it is possible to display an image with a pixel size different than the resolution. Images where only large features are visible are said to have coarse or low resolution. In fine or high resolution image, small objects can be detected. Now we will discuss about spectral resolution. The second important property of an optical imaging system is its spectral resolution. The spectral resolution is an important experimental parameter. If the resolution is too low, spectral information will be lost, preventing correct identification and characterization of the sample. If the resolution is too high, total measurement time can be longer than necessary. Different classes of features and details in an image can often be distinguished by comparing their responses over distinct wavelength ranges. Broad classes, such as water and vegetations, can usually be separated using very broad wavelength ranges, the visible and near infrared. Spectral resolution describes the ability of a sensor to define 5 wavelength intervals. The finer the spectral resolution, the narrower the wavelength range for a particular channel or band. Many remote sensing systems record energy over several separate wavelength ranges at various spectral resolution. These are referred to as multispectral sensors. Advanced multispectral sensors called hyperspectral sensors detect hundreds of very narrower spectral bands throughout the visible, near-infrared, and mid-infrared portions of the electromagnetic spectrum. Their very high spatial resolution facilitates fine discrimination between different targets based on their spectral response in each of the narrow bands. Next is radiometric resolution. While the arrangement of pixels describes the spatial structure of an image, the radiometric characteristics describe the actual information contained in an image. Every time an image is acquired on film or by a sensor, it's sensitive to the magnitude of the electromagnetic energy and determines the radiometric resolution. The radiometric resolution of an imaging system describes its ability to discriminate very slight differences in energy. The finer the radiometric resolution of a sensor, the more sensitive it is to detecting small differences in reflected or emitted energy. Next is temporal resolution. Temporal resolution can be defined as time needed to revisit and acquire data for the exact we discussed this in remote sensing. This amount of time depends on the orbital characteristics of the sensor platform as well as sensor characteristics. Temporal resolution is usually expressed in days. The revisit period of a satellite sensor is usually several days. Therefore, the absolute temporal resolution of a remote sensing system to image the exact same area at the same viewing angle A equal to this period. However, because of some degree of overlap in the imaging swaths of adjacent orbits for most satellites, the entire is overlap with increasing latitude. Now we will discuss about optical, near-infrared, and thermal imaging sensors. The aim of this section is to provide brief details of a number of sensor systems operating in the visible and infrared regions of the electromagnetic spectrum, together with sample images in order to familiarize the reader with the nature of the digital image products and their application. First is Along Track Scanning Radiometer, ATSR. The Along Track Scanning Radiometer, ATSR, is a new generation infrared radiometer which was built specifically to supply accurate measurements of sea surface temperature for environmental and climatic applications. It has 3 TIR bands, channel centered at 3.7 micrometer, 10.8 micrometer, and 12 micrometer, plus an IR channel centered at 1.6 micrometer. These thermal channels correspond to bands 3, band 4, and band 5 of the NOVA AVHRR. The main product has been validated against accurate surface measurements and is now available to the research community for using global and regional climate models. A replacement instrument, ATSR-2, has just been successfully launched on the ERS-2 satellite. ATSR-2 is a development of ATSR and has additional channels centered at wavelengths of 0.555, 0.659, and 0.865 micrometer that are intended for land applications. It is carried by the ERS-2 satellites, which was launched in April 1995. An extended version of ATSR-2 is called the Advanced Anong Track Scanning Radiometer, AATSR, is carried by the European Space Agency's ENVISAT-1 satellite, which was launched in 2002. The AATSR has 7 channels. Next is Advanced Very High Resolution Radiometer, AVHRR, and NPO-ESS. Yes, ma'am.
Quickly wind up the presentation.
Yes, ma'am. AVHRR instrument is a space-bound sensor that measures the reflectance of Earth in 5 spectral bands that are relatively wide by today's satellites. The instrument scans several channels. 2 are centered on the red 0.6 micrometer and near infrared 0.9 micrometer regions. A third one is located around 3.5 micrometers, and another to the thermal radiation emitted by the planet around 11 and 12 micrometers. The National Polar Orbiting Operational Environmental Satellite System is a tri-agency program designed to support the missions of the NOAA, the Department of Defense, and the National Aeronautics and Space Administration. VIIRS represents a dramatic improvement over the NPO-ESS mission in the visible infrared image radiometer suite. VIIRS represents a dramatic improvement over the advanced very high resolution radiometer and incorporates many lessons learned from the moderate resolution imaging spectroradiometer. Next one is MODIS. MODIS is a wide field of view instrument that is carried by both the US Terra and Aqua satellites. They capture data in 36 spectral bands ranging in wavelength from 0.4 micrometer to 14.4 micrometer and varying spatial resolutions. Next is IRS satellite series. The Indian Space Program has the goal of harnessing space technology for application in the areas of communication, broadcasting, meteorology, and remote sensing. The important milestones were Bhaskara 1 and Bhaskara 2 in 1979. The experimental satellites which carry TV cameras and microwave radiometers. And there are after that there were a series of satellites which was launched into the space. Now we will discuss about Landsat instruments, Landsat multispectral scanner, MSS. Some of the important features of this is.
Yes, Vardhan, yes, your time is over.
Okay. Thank you, ma'am.
Yes, welcome. Coming to the next, yes, Arun.
Yes, ma'am.
Yes, start the presentation.
Ma'am, is it visible?
Yes, it is visible.
Already, yes. Ma'am, my presentation is visible to you or not?
Yes,
Hello,
your
ma'am.
screen is visible, Arun.
There is some lag. Okay, so good afternoon, everyone. Today is my presentation on remote sensing platform and sensor. So we are very familiar different kinds of remote sensing platform, and there are a few like ground-based, airborne, space-borne. But when we talk about sensor, it's quite interesting. So I begin with introduction, and later I cover all kind of sensor. So introduction. So with the help of remote sensing platform, we are able to get the digital image of Earth surface, and it makes it easy to us for determine the what kind of nature and characteristic. And three developing area of remote sensing using spectrometer. interferometer is SAR, and the LiDAR sensor. Most wide used satellite-borne imaging instrument like HRV, which is used by spot satellites, and Landsat use the TM and ETM, and Aster, and the last one SAR, synthetic aperture radar by RadarSat 1 and 2. So what's the general characteristic of imaging remote sensing instrument? So first one, a remote sensing instrument operating in optical band whose wavelength is less than 3 micrometer, and namely there are spatial, spectral, temporal, and radiometric resolution. And the next one is about the three images here represent. The first top one is taken by Meteosat series satellite, and the right top one is taken by the NOAA, and the last one is taken by Landsat. So Meteosat is a series of satellites, geostationary meteorological satellite. It is an geostationary satellite, so above equator. So, and the next one is NOAA, which is stand for National Oceanic and Atmospheric Administration. And so Landsat and Spot satellites are polar orbiting. And the next one is temporal resolution. So temporal resolution of a polar orbiting satellite determined by choice of the orbit and perimeter altitude, like orbital altitude, shape, inclination. Through this equation, T is equal to 2 pi r, root r by gs something. With the help of this equation, we obtain the orbital determination, and where small r represent the radius of Earth plus orbital height. And next one is so Landsat and Spot are the sun synchronous orbit satellites. And next one is characteristic of Indian remote sensing instrument. So when you're talking in imaging remote sensing instrument, it operates in visible, infrared in terms of their spatial, spectral, radiometric resolution. And Meteosat's image are generally used for global scale. And with NOAA satellites have a repetition cycle of 24 hours. Next one is medium resolution satellite such as Landsat and Spot. It allows for the regional studies. And next one is high resolution system, have a resolution of less than 1 meter. It's mostly used for local studies. The next one is spatial resolution. When you're talking about spatial resolution, so the geometrical property is most important thing here, because we able to distinguish the point target, able to measure the periodicity of repetitive measurement, and ability to measure the spectral property of a small target. The important concept of IFV, everybody is familiar with what is IFV. But when I'm talking about PSF, like what is PSF, point spread function. So with the help of PSF, how the resolution is vary. Like just before PSF, Landsat 1, 2, 3 MSS scanner have a resolution of 79 meter. But with the help of PSF, the resolution getting enhanced. So Landsat 4 and 5 thematic mapper have a resolution of 30 meter. Next one is spectral resolution. Spectral resolution is an important property of optical imaging. There are some satellites such as ERS, TerraSAR, Helios, Pulsar, RadarSat, and they are all used to collect microwave SAR images. For panchromatic image collection by Worldview, Iconos, Spot, HRV, Landsat 7. Spectral resolution refer to the width of the spectral band measured in micrometers or nanometers. So first one, the position in the spectrum, width, and the number of spectral band determine the degree of the individual target. And second one is the use of multispectral imaging leads to the higher degree of discriminating power than the single band taken. And the next one is CZCS. CZCS they stand for Coastal Zone Color Scanner, which is taken by Nimbus 7 satellite, and it is used for ocean ordering instrument, ordering satellite. The next concept of SNR, signal to noise ratio. Signal to noise ratio measure the purity of signal. Increases with the spatial resolution, we reduce the SNR. Next one is radiometric resolution. So when we're talking about radiometric resolution, it refers to the number of digital quantization level. In general, greater the number of quantization level, the greater the detail in the information. So for two level, or black or white, the number of bits required per pixel is 1. While for 1664 256 level, the number which required is about 246 bit. And next one is the relationship between leaf property and reflection, transmittance property are quite sensitive to radiometric resolution. It is used the measure known as entropy. So this equation H is equal to minus summation pi log something is equation which is used for entropy, and here pi just for probability level, and when we calculate the pi is in terms of frequency and divided by number of pixels. Next one is ATSR. ATSR stands for Along Track Scanning Radiometer. So it is a single band grayscale image. It is processed by a technique called the pseudo color. So in this image, you easily understand how the pseudo color vary. Like blue color, here blue color represent the cold, and the yellow and the red represent the warm. So it has 3 TIR channel plus 1 NIR channel. This thermal channel correspond to band 3, 4, 5 of NOAA and AVHRR. Basically, it is used for measure of global sea surface temperature. And ATSR2, called the Advanced and Long Tracking Scanning Radiometer, is carried by European Space Agency, ESA, InviSat-1 satellite. It has a 7 channel, and spatial resolution of visible and VNIR channel is about 500 meter. The infrared channel have a resolution of 1 meter. Next one is AVHRR and POESS VIIRS. So both stands for, first one AVHR stands for Advanced Very High Resolution Radiometer, and the second one stands for National Polar Orbiting Environment Satellite, and VIIRS stands for Visible / Infrared Imager Radiometer Suite. So in AVHR carried by NOAA for the purpose of meteorological observation. It is used in land cover at global and continental scale. TIR channel used for sea surface temperature, where VNIR channel used for land surface such as snow, ice melting, or vegetation status using the vegetation indices such as NDVI. So NOAA 19, launched in February 2019, is the last television infrared observation satellite TIROS series. It carries the AVHRR3 and HIRS4 instrument. HIRS4 is used to collect atmospheric profile in visible 1 and 7 mid-infrared 12 long wave. So TIROS program replaced by the NPOES. Okay, so image collected are provided in visible infrared radio VIRSS, which has 9 VNIR channel, and spatial resolution of the instrument is about 400 meter. And the next one is MODIS. MODIS stands for Moderate Resolution Imaging Spectrometer. MODIS is carried by US Terra and Aqua satellite. It is a conventional radiometer using scanning mirror, measure 36 spectral band. Spatial resolution band 1 and 2 is about 250, band 3 to 7 is about 500, and band 8 to 36 about 1 kilometer of resolution. This product includes surface temperature, surface reflectance, land surface temperature, emissivity, land cover, leaf area indices, and lot. Next one is ocean origin instrument. The sensor, there are some sensor like CZCS, CWIFUS, OceanSat2, MODIS. And these are all ocean origin instrument, and we already talked about what is CZCS. It's a sensor carried by Nimbus 7. So next one is
Arun,
Nimbus.
quickly wind up your presentation.
Okay, ma'am. So Nimbus 7 satellite, Nimbus satellites near polar and sun synchronous, and next one is OCTS, Ocean Color and Temperature Scanner, has a just abroad by Japanese EDIOS and CWIFUS, and all are these are ocean sensor like IRS. LISS stand for India Remote Sensing Linear Imaging Self-Scanning Sensor. First IRS satellite Bhaskar 1, LIS 1 has a resolution of 36 meter. LISS and LISS 2 has a resolution of 25, and the next one has a resolution of 5.8. So, and the next one is the Landsat instrument. First one is Landsat MSS, has a resolution of 60 meter, and Landsat was originally called the Earth Resource Landsat Technology Satellite. It is a satellite by NASA and the first Landsat observation satellite by civilian. And next one is about later 2 set of Landsat which use the return beam videocon RBV, have a channel 1, 2, 3, and and last one next one is the Landsat thematic mapper. it's carried by the Landsat 4 and 5. Landsat 4 and 5 has a resolution of 120 meter, and ETM carried by Landsat 7. Next one is enhanced thematic mapper. Why we need an enhanced thematic mapper plus? Because detect the occur carried improvements version of ETM has a resolution of 15 meter resolution panchromatic and 120 meter in thematic mapper. And the next one is Landsat data continuing mission. It carry the operational land imager. Spot sensor. Spot program is operated by French Space Agency. Spot 1 is launched in February 1986, called the HRV instrument capable to measuring upwelling radiance and a special resolution of 20 meter. In single panchromatic channel has resolution of 10 meter. All channel quantized to 0 to 255 scale. And next one, same vegetation. Spot 4 and 5 has a scanner sensor called VGT. VGT operates in same wavelength, and VGT has advantage of land application. And next one is ASTER. It is an imaging sensor, stereoscopic capability, and its work in VNIR, shortwave IR, and TIR. And about resolution, VNIR has a resolution of 50 meter, SWIR resolution of 30 meter, and TIR have a 90 meter resolution. Next one is high resolution commercial and small satellite. So this is a small satellite, so we easily understand it carries a single sensor, and the name is Iconos Satellites GUI. And panchromatic has a resolution of 1 meter, and spectral band have a resolution of 4 meter. Next one is
okay, Arun, stop the presentation.
Okay, ma'am.
Next, Arun.
Yes, ma'am. A very good afternoon to everyone. So I'm presenting on remote sensing and its basic principle. So the word remote sensing, it is made of two words, remote and sensing. And if we observe something from a distance, we call it remote sensing. So remote sensing is a method of obtaining information about a physical property of Earth without coming into physical contact with it. And in remote sensing, what we do, we capture the radiation in different wavelength of the spectrum, and we recorded the Earth feature, Earth surface feature, directly through air photography or through satellite imagery. So remote sensing data is very important for us because it is used in various domain, and in very short time we also get the remotely sensed data. So it used in various domain like natural resource management, meteorology, environment, urban planning, etc. So where we use the remotely sensed data.
Arun, are you changing your slides?
Ma'am, yes, ma'am, I'm changing.
No, it is not visible. Please share it again.
Yes, ma'am. So,
yes, place it in a slide. It's a slideshow mode.
Yes, ma'am. It is on slideshow mode.
Share your screen again. In this case, instead of using just this PowerPoint, use entire screen option.
Okay, ma'am. Okay, ma'am.
Yes, it's okay.
So where we use remotely sensed data. So this green color showed the product derived from remotely sensed data. What are the product of remotely sensed data? We get a land use, land cover or classified image from satellite imagery. We also get various parameter, various other thematic information from remotely sensed data like soil moisture content, surface temperature, land leaf index, etc. And there are various technique or computer processing technique which we used for the to derive these information. So these are pattern recognition, enhancement, various pre-processing technique, also like enhancement, contrast, brightness, sharpening, and various filter to enhance the image. To These technique are used to derive the product. Now electromagnetic radiation. So EMR is a form of energy emitted and absorbed by charged particle which exhibit wave-like behavior as it travel through space. So EMR has two component. One is the electric field and the other is the magnetic field. And these two fields are perpendicular to each other and also perpendicular to the direction of its travel. Then the transfer of EMR is in remote sensing. The transfer of EMR radiation is our primary interest. So there is a wavelength. Wavelength is a distance between two successive peak, and a frequency. Frequency tell us the number of cycle per second passing a fixed point. So this is electromagnetic spectrum. So electromagnetic spectrum ranges from it has a long wave wavelength and also like radio waves and short wave wavelength. But our eyes are able to see the spectrum from 0.4 to 0.7. That is why this range is also known as visible range. And there are two type of sensor which is used in remote sensing. The one is passive sensor and the second is active sensor. So passive sensor, they do not emit radiation by themselves. And for example, the multispectral sensor like Landsat ETM or Landsat 7, 8, and active sensor like LiDAR and radar sensor like radar set is a radar sensor which have their which emit radiation by themselves. Then there is a two type of scanner. The first one is wishbone scanner and the second is pushbroom scanner. So the wishbone scanner is also called as across track scanner. And it scan the earth in a series of line, and so as it is known as across track scanner, it uses a mirror to reflect light on a single detector. And in this type of scanning, the lines are perpendicular to the direction of motion of the scanner or the platform, like in figure 1. And the second one is the wishbone scanner, which uses wishbone scanner utilizes a mirror that wishbone scanner have the mirror which swipes in a direction perpendicular to the flight path, and it has a mirror across the path. That is why it is known as a cross track scanner. And then the other is a long track scanner which is called a push broom scanner, and it also it uses forward motion of the platform to record a successive scan line. And so and also have a CCD. So the push broom scanner also have a solid state CCD detector, and that is a charged coupled devices, and it uses a single point on the scan line. So it observes the earth feature as a single point. Then there is various terminology used in the chapter. The first one is the radiant energy. So radiant energy is the energy associated with electromagnetic radiation, and the second is the flux of energy. So the flux of energy is the rate of transfer of energy from one place to another. So for example, like sun to earth, the transfer of energy is known as flux of energy. The third one is radiant flux density. So it is the rate of transfer of radiant, that is EMR, energy or radiation. And the density in this radiant flux implies the variability over a two-dimensional surface on which radiant energy falls. The fourth is radiance. So the radiant flux density is transmitted from a unit area on the Earth's surface through a unit solid angle is called radiance. And the fifth is reflectance. So it is the ratio of the radiant emittance of an object and the irradiance. Sorry, ma'am, I have not properly made the PPT.
Okay, Parul.
Okay.
And I think so everyone has given of the presentation. Is anybody left who want to give the presentation? Okay then. So this chapter number 2 of Paul Mather's book is about remote sensing platform and sensors. This chapter starts with some of the basic introduction, like what is a spatial resolution, spectral resolution, radiometric resolution, and thereafter there is a very detailed discussion about the different remote sensing platform, different satellites, the sensors that are mounted over there, and other things. If we start with this one, it first gave you some of the formula, like what is the orbital, means whenever there is a satellite, it will orbit around the Earth. So what is the orbit period? There is a standard formula, T equal to 2 pi underscore small r divided by gravitational acceleration. In this case, it is Earth. Multiplied by r square, where capital R is the radius of the Earth and small r is the radius of orbit, which is radius of the Earth plus altitude of the satellite. So it is small r equal to capital R plus h. This one is a standard formula that you must have already studied in the physics in class 11th and 12th. You must have studied this formula. So this one is the orbital time period. Next, there is one important term that is given over here is sun synchronous. Okay, everyone remember this term sun synchronous, because most of our satellites, or the one on which we used to work, they are mostly sun synchronous. So what is the meaning of the sun synchronous? It is written over here, when something visit on the same time. Okay, just wait for a minute. It's this one. So when the satellite passes over a given point on the Earth's surface at the same sun time each day, then they are called sun synchronous. Why this thing is important? Why we consider the sun synchronous thing? Because, you know, at different time in the previous chapter, in chapter number 1, you have learnt about the sun's zenith angle, its altitude, its azimuth. Okay. when you take the same sun time of each day, in that case, what will happen? The position of the sun is more or less same. The azimuth of the sun, which is the angle from the north direction, will be same. That's why the illumination condition is same at the same anniversary data. Means if you take the data of say, today is 10th of January, so 10th of January 2021 and 10th of January 2022. So if you take the anniversary data, the position of the sun will be same. That's why the sun synchronous is important, especially in the change detection related studies when we use to interpret the image. Okay, and if the position of the sun is not same, then the interpretation will also not correct. So there is a seasonal effect, because according to the season also the position of the distance between the sun and the earth varies. So all of these things have an effect. That's why later on you will learn that many times we used to prefer the anniversary data. And means if you go for the Landsat, like 16 days is the revisit period. So you will not get the anniversary data, but near to the anniversary data, like suppose I am planning for the March, so 15th March, another image might be of 7th of March, another one maybe of 24th of March, something like that. So sun synchronous is the important term. Write it down in your copy. And whatever terms I am telling you, make sure that you have a proper definition of these things. Like during the Viva session, it is observed that the students know the things. Means some of the students know the things, not all. But even those who know that thing, they are not able to express that thing in proper terminology. Therefore, prepare the answer of these questions. Like, so if suppose somebody asks you what is sun synchronous orbit, you should be able to answer that. What is near polar orbit, you should be able to answer that one. So prepare like a glossary, prepare the definition of all these things. What is the meaning of sun synchronous and other related terms. Now coming to the another part of this one, it gives a very detailed discussion about the spatial resolution. Okay, so this book is like a research paper. They give the different aspect of the spatial resolution, how it is defined by different people, by the different researchers. But in the simple terms, I am not going into that detail. In a simple terms, if somebody asks you what is the spatial resolution, the common answer is that we used to say it is the minimum distance between two objects that the sensor is able to distinguish. It is one of the way of saying the spatial resolution, that if the distance, as it is given over here, if the distance between the object is more than spatial resolution, in that case we are able to view the object. Now, if you see this one, okay, there is one of the relationship between IFOV, which stands for instantaneous field of view. First thing is, what is IFOV? If any of the detector like this one is placed over here, there will be alpha. View angle is over here, alpha. The area which is seen by this one is called IFOV, instantaneous field of view. So it is given over here. The most commonly used measure based on the geometric properties of the imaging system is its IFOV, which is defined as the area on the ground that is viewed by the instrument from a given altitude at any given instant in time. The IFOV can be measured in one of two ways, as the angle alpha or the equivalent distance xy on the ground. So in simple terms, spatial resolution is minimum distance that is distinguishable by the sensor. Now, which spatial resolution should we select? It depends upon our application. Okay, it depends upon the availability of data. If you go for a very high resolution data, it will be less than 1 meter. Okay. The medium resolution, like usually we go for the Landsat because it is the open source data. In that case, we have 30-meter resolution nowadays. Sometimes when we need to go for a global coverage, the resolution will be in kilometer also. Okay. Yes. There is some disturbance. So depending upon the requirement, the resolution is selected. It is not always like, the high resolution data is always the best. No, it's not true, because if you go for the high resolution data, then the size of the data will be increased. And if somebody is working on a global coverage, like suppose my study area is pan-India data. In that case, if I take 1 meter resolution or less than 1 meter resolution, I cannot even work on the whole data set unless until I have a very good machine that can work on that much resolution. Okay, so depending upon the application, most of the meteorological satellites, if you see, they also have a very low spatial resolution. Next thing is spectral resolution. Okay, again, what is a spectral resolution? In simple terms, we say it depends upon the number of bands in which the data is sensed. Now, if we see the definition of this one, the term spectral resolution refers to the width of spectral bands measured in micrometer or nanometer. Now, depending upon the spectral resolution, there are a few things that they are saying: the position in the spectrum, what is the width of a band, what is the number of bands, it depends upon the spectral resolution. Okay. If you see the effect of resolution over here, as you can see on the screen, there are two data. First one is the ASTER data. Okay. Second one is the Landsat data. So ASTER is the example of, or AVHRR, these all are the example of hyperspectral data. When we take the Landsat or SPOT or LIST, anything like that, they all are the example of multispectral data. As you know, the hyperspectral data has hundreds of bands, some 200, 300, something like that. If you see the multispectral data, it will have somewhere 10, 12, something like that. Nowadays, the number of bands even in the multispectral data has increased. Now compare both the graphs. Okay, both are showing the same graph of the vegetated surface leaf from a deciduous tree. Okay, both are showing the spectral reflectance of a deciduous tree leaf. See the difference between the hyperspectral data and the multispectral data. What is the difference between the spectral plot? Okay. If you see the spectral signature of this first one, you are getting a continuous data over here, isn't it? And when you are seeing the multispectral data, Landsat data in figure B, you are not getting a continuous data. You are getting a scattered data. So it is not possible to give a continuous or sometimes contiguous, not continuous. In this case, it is continuous, but sometimes it can be contiguous. So you can see the difference between these two data sets. So certainly in case of hyperspectral data, where the spectral resolution, the whole exercise I am doing is to explain the spectral resolution. So you can see the impact of spectral resolution over here, how the number of bands are impacting the output. In case of hyperspectral data, you are getting a continuous picture. In case of hyperspectral data, the continuous picture is not available. Why? Because there are just only 7 bands in which the remote sensing has been done. So this is what the difference in the hyper and multispectral data. Again, the same thing. Just like the spatial resolution, here also, highest amount of spectral resolution is not always good. It is not always good to work on the hyperspectral data as compared to the multispectral data. If you ask me why, because again, if you see the size later on when we learn about the hyperspectral analysis in this course, later on you will learn that there is the concept of image cube over here, because there are so many bands in case of hyperspectral data that it becomes a cube instead of a 2D surface. We will discuss it later on when we start the hyperspectral data. But the thing is, when we work on the hyperspectral data, the number of bands is quite large. So it is not easy to handle the hyperspectral data. Handling of hyperspectral data is much more difficult than the multispectral data. When you start working on the hyperspectral data, the working of multispectral data will appear so easy to you, because the regular classification, pre-processing, everything is comparatively difficult in the hyperspectral data as compared to the multispectral data. Apart from that, there is a problem of redundancy over there also. Isn't it? If you take very narrow spectral band, in that case, several band will convey you the same information. Why? Because the size of the band is very small. So there is a problem of redundancy in the hyperspectral data, and when we work, we just need 3 bands, isn't it? When you represent any of the image, you can take only 3 bands. Through that, you can give RGB, the red color, blue color, green color to them, and there is how you will create a composite image, colored composite image. So you can create a true color composite, you can create a false color composite, whatever you like to do, you can do it. When you work on a multispectral data, selection of 3 band is very easy. Out of 7, you just need to select 3 band. It is very easy. But when you go for the hyperspectral data, among 200 bands, you have to select 3 bands. In that case, it is difficult. Okay. So this is what this is spectral resolution. There is few things that I have highlighted over here. Read this thing, this particular section very carefully. This one is about the push broom scanner. Okay, this is a very obvious thing which is written over here. You might know it very well. Like I'm just reading it out. So push broom, is it a long track or a cross track? Anyone? Push broom scanner is the along track scanner or the across? Yes, it is a long track. Yes, it is a long track. What is the name of a cross track scanner? It is whisk broom scanner.
Electromechanical.
Yes. So these are 2 types of scanner. In general, we use the term a long track or a cross track. So sometimes it is push broom or whisk broom scanner. If anybody has any confusion, just think how you clean the room, how you are placing your broom. So on the basis of that one, you can think or you can quickly visualize what is push broom, what is whisk broom. Okay. So the push broom is the long track scanner. So whether it uses the mirror or the CCD, which one is used with the push broom scanner or the along track scanner? Oscillating mirror or the CCD device?
Array of CCDs.
Yes, it uses CCD. Across track scanners or whisk broom scanners uses the oscillating mirror. But in case of along track scanners or the push broom scanner, they uses the CCD devices. So here, the push broom type of sensor is a linear array of individual detectors with 1 detector per scan line element. The forward movement of the sensor. Yes.
Ma'am, what you are displaying that is not being displayed in our side. That multispectral and hyperspectral graph is only being displayed. Bar graph one.
I think so. It must be visible by now. So I'm reading it out. The push broom type of sensor is a linear array of individual detectors with 1 detector per scan line. The forward movement of the sensor form the image 1 scan line at a time. This arrangement provides for longer look at each scan line element. So more photons reflected from the target are collected, which results in a better SNR, signal to noise ratio, than does an electromechanical scanner employing a single detector which observes each scan line element sequentially. The time available to measure the energy emanating from each point along the scan line, which means dwell time, is greater for push broom scanner because the individual detector sees more photons coming from a given point than the detector in an electromechanical scanner, which looks at a point for a shorter times. Hence, narrower bandwidth and larger number of quantization levels are theoretically possible. Okay. So I'm just trying to cover this point so that you will know the difference between the push broom and whisk broom scanner, because many times when there is a question, what is the difference between these two types scanner? What is the difference between the along and across track scanner? There are some other things which are mentioned over here. Okay, it is not just about that one is using the oscillating mirror, another one is using the CCD. There is just one difference that majority of time students used to mention. So I am giving you this particular section, write it down in your copy, mug up this section so that you should be able to answer this question very properly. What is the difference between the push broom and whisk broom? Why the along track is better as compared to across track sometimes? Everything is given over here. Okay. So just go through this particular. Yes.
Which page number is that?
The screen is visible or not?
No, ma'am. Only S is coming.
No, ma'am.
No, ma'am.
Screen is not visible to anyone?
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
Okay. Is it visible now?
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
Okay. Then I will leave the meeting and join again. Is it visible now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So it is page number 37. I have highlighted this content. Page number 31, the very first paragraph of the page number 31. Okay. So this section is specifically means telling just about the difference between the push broom, and they are telling that, they are using one CCD per scan line, and second thing is they have longer amount of time when you use the along track as compared to across track. The detector has more time. More time means it will get more photons. Since the dwell time is more, therefore it will get more photons. Therefore, the quality of signal will be better in case of along track as compared to the across track. And that is why it is possible to collect the data in the narrower bandwidth as compared to the across track. Coming to the next resolution, which is the radiometric resolution. So radiometric resolution means how many bits. In simple terms, again, if I say what is radiometric resolution, it is the number of bits in which the data will be expressed. It can be in 2-bit data, 8-bit data, 16-bit data, something like that. So radiometric resolution or radiometric sensitivity refers to the number of digital quantization level used to express the data collected by the sensor. In general, the greater the number of quantization levels, the greater the detail in the information collected by the sensor. The example is given over here. I think so it must be visible to everyone. This example, figure 2.7 is visible.
Yes, ma'am.
Yes, ma'am.
So this one is showing the different radiometric resolution over here. And when you see this one, the very first one is a binary image. It will have just 2-bit data. So either 0 or 1, sorry. Yes. So 2 gray level is available over here. When you use a 2-bit data, in that case, it will be 4. So it is a 1-bit data that which is given over here. So it is binary image, black and white. Now, if you see the comparison between the second and B and C, okay. If you compare between the B and C, both are appearing in the gray scale, but first one is using, B1 is using the 16 gray levels and second one using 256 gray levels. So this one is 16 gray levels and this one is using 256 different gray levels. Although they are appearing more or less same, but if you see that this thing very minutely on your own screen, you will find that there is a difference in shading as compared to B and C. So this is the radiometric resolution. Yes, there is a term called quantization. The term quantization means breaking down a continuous range into a discrete number of levels. This is what the quantization is. Breaking down a continuous range into a discrete number of levels. Now coming to the another part of this one, the next part is completely about different type of missions that were taken place in the field of remote sensing. Majority of them are already covered by your side, but one of them which is very important is Landsat. Rest of them are also useful. But since in this course we are repeatedly going to discuss about the Landsat, so remember, first of all, 2.3.5, which is Indian Remote Sensing List series. So since this one is the Indian satellite mission, therefore go through this one. Remember the things over here. They might not be important for the coursework, but they are very important for, when somebody asks you from the outside in the interviews and other places, the questions which are related to the Indian mission are common. Okay, so that's why I learn about this IRS list because it belongs to our own nation. We must be aware what is going on or what was the history of our own remote sensing missions. In the course throughout, we will never work on the list or we will not have the example of the list much. One or two will be there. Or most of the work will be done on the Landsat, okay, which is the US mission. But IRS is our own mission. This belongs to our own country. So go through the IRS and this 2.3.6, which is the Landsat. Now this one is very important. Throughout the SIP course, there will be example of Landsat. Okay, even in last 2 or 3, this one is a third lecture. In every lecture, you must have listened from my side the term of Landsat. The Landsat is very important. It is very useful. Even in your thesis work also, if you will work on this, means maybe on the remote sensing topic or image processing topic, in that case also you are going to use the Landsat data. Landsat is one of the freely available data. That's why it is very popular. In many of the books also, you will find the example of Landsat. Like if you go through the Mather's book or Jensen's book of remote sensing, everywhere you will find the examples of major examples of Landsat mission only. So that's why this one is important. If you talk about the Landsat series, the Landsat one was launched in the year 1972. Okay, initially, instead of Landsat, it was named as Earth Resource Technology Satellite, ERTS-1. And thereafter, it was renamed as Landsat. Landsat has different sensors. Initially, as it is given over here, there is radio beam, Vidicon, RBB, and some other such sensors. But they are of not much use of today. And you need to learn what is MSS, multispectral scanner. Thereafter, what is TM, thematic mapper. After the thematic mapper, there is the ETM plus. Okay. After the ETM plus, from the Landsat 8, there is OLI, operational land images. Nowadays, if you see the recent Landsat data, it is of OLI. Okay, and very recently, probably in, I think so in October, Landsat 9 has been launched. Okay, so just wait for a minute. Yes, it was launched on September 27th, 2021. Okay, so this one is the latest satellite. The data may have been started to come. It will take some time for the data to come. So we have to check for that one. But recently the Landsat 9 has been launched, and before that Landsat 8 was launched. So you will have the OLI, operational land imager data of Landsat 8 was there. That data has been used. Okay. So you need to go thoroughly through the Landsat mission and the IRS mission. The rest of the missions are useful. You must know about them, but these two missions are very important. The SPOT, this one is of French satellite. This one is also very popular because it has been started very earlier. Then there is a complete discussion about the high resolution data set. At least you must be aware about the name of your such satellites, okay? Because I also can understand that it is not possible to remember or mug up everything. So I am also not expecting anything like that from your side, but at least you must know the name of these satellite, okay? So remember the name of the satellite, a little bit about them, some approximate resolution of those one you must remember. Like, you know, if somebody asks you what is the resolution of Iconos, you must not say that it is 30 meter, okay? It is, which is outrightly incorrect, because everyone know that Iconos is a high resolution satellite data. So whenever, even if you do a guesswork, it must make some sense. So I'm not telling you to mug up everything, but at least try to get this thing that if it is a high resolution, if it is a QuickBird, if it is Iconos, if it is a world view, something like that, they all are the high resolution. Their resolution must be less than 1 meter. So give the answer which is near to the actual value. Okay. So remember the name of these satellites, but go thoroughly through the Landsat mission and the IRS, Indian Remote Sensing Mission. Okay. So that's it from my side for today. From next term, which is on Wednesday, we will start the syllabus of satellite image processing. We have done enough revision of the remote sensing. Yeah, one more thing that I want to tell you regarding the presentation. You know, the chapter number 2, the length of the chapter number 2 is quite long, and it is not possible to cover everything in the 10 minutes. So when you are doing such type of thing, when you are making a presentation of something which is very lengthy and you have to cover it in 10 minutes, try to include all the topics, but don't try to read out everything, because if you start reading out, you cannot complete it in 10 minutes. Isn't it? So place the content, give an overview of every topic. Like I have covered this thing, I have not read it out everything. So if I start reading out everything, then I cannot cover everything. So put the content according to that one, cover the things, try to accommodate all the topics so that it will not appear that you have missed several of the topics. Okay. So thank you everyone. That's it from my side today. And on Wednesday, we will start to study about the statistics which are related to the images. What is the univariate statistics? What is the multivariate image statistics over there? That one will be the introduction of the SIP, and thereafter we will start with pre-processing. Okay then. So thank you so much. The class is over for now.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yes, welcome to everyone.